Hello, everyone. Hola, and thank you for having us here on this console conference of this year. We are here to talk about a solar cooker we built on the coast of Kenya. It's a parabolic trough style collector. We have used it to cook potatoes and some other stuff, but that wasn't our motivation for building it. We are in the process of building a 50-ton sailing dhow, a sailing boat out of plastic waste, and we needed a way to heat our giant parts. And on the coast of Kenya, the sun is one very reliable source of energy. So let's start with a short introduction of who we are. We are Katarina Eleke and Michael Macris, industrial designer and mechanical engineer. And for the past few years, we've been involved in projects developing solutions to tackle the plastic waste problem. At Precious Plastic, we help to develop machines and online tools, open source, to make plastic recycling more accessible for everyone in the world. And at Flip Floppy, we've built the first sailing dhow from plastic waste collected along the beaches of Kenya, and are taking this boat on expeditions to spread awareness, connect, and inspire more people to change their perspectives and act towards a plastic-free environment. And we've already inspired a lot of change on individual and political level. But now we are working on a big boat to bring it to the next level and take this positive symbol and change around the world. But with this big recycled plastic boat come new challenges we have to overcome. So a quick note for a general understanding. The principle of plastic recycling works like this. You can heat plastic up until it melts, and when it's soft, you can turn it into different shapes, basically any shape you want. And when it cools down again, it hardens. So basically just like chocolate. And in the case of this big recycled plastic boat, we are going to make big parts from recycled plastic. So we will need a lot of heat over a big surface and volume and over a bigger amount of time because it takes longer to manufacture those parts. And that requires a lot of energy. And as in Kenya, electricity is not as easy to get and maintain, while you do have a lot of sunlight, that brings us to our solar cooker. And actually, we're not the first ones who had the idea of using solar cookers for plastic recycling. In our Precious Plastic recycling community, we've already seen some people building and using smaller solar units for smaller injection volumes and for plastic extrusion processes. So seeing that working in our community encouraged us to apply solar on our project too.
Hello, my name's Michael. Thanks for having us both at this year's conference. And I'm here to talk a little bit about the design and testing of our cooker. Even though our application was centered around processing plastic, we still think we have some transferable design features and findings to share, so hopefully it's valuable for you. So first, looking into the different ways to heat our molds, we were looking for a method that could heat a large volume reliably and for a reasonable price. We were aiming for temperatures in the region of 160 to 240 degrees Celsius, so a solar cooker ended up being a serious contender. So looking into the different kinds of solar cookers, there was one format which was very suitable for making boat parts, which are essentially long beams, and that was a trough style collector. The idea was to use one of these as an auxiliary device in order to keep our molds hot during the longer than usual injection period. And here's a picture of me doing that. You can see on the left me pouring plastic into the extrusion machine, hooked up to our mold that's being heated by the solar cooker. The whole process for this part took 7 hours to fill just the mold. And it worked really well. We would have never been able to make this part without additional heat. In fact, here are a couple of beams that didn't work because we made those ones on cloudier days. So one design feature that we built in was the ability to join many of our solar modules together into a chain which can give us any length of oven that we want. The modules can be joined together with bolts, and the oven parts mate with each other to make a long continuous oven. You can also swap out the receiver, or in our case, the mold, for a different one. For us, this modularity was important for production of continuous plastic parts and different kinds of beams for the boat. But even for food, keeping it modular like this could be useful to enlarge existing ovens in the future or keep costs down for building very large ovens. So since our receiver's cross-section was a rectangle, we wanted to optimize the parabolic form to provide an even distribution of light to the receiver. So we modeled this geometrically and parametrically in our CAD software. So this allowed us to change our input parameters, such as the receiver dimensions, and for example, the size of the reflective surface, and have our form automatically generated based on our requirements. So this was a great way to quickly generate forms for different shapes and different parts, very quickly and reliably without too much maths. This sketch then dictates the geometry of our structure, which we then laser cut for maximum precision. So one area of improvement for us was to have the point of rotation about the central axes of our receiver. This is because our receiver is connected to external machinery, so ideally this connection point should stay in the same place and not translate. The other thing was that for the size of the receiver, we were on the edge of being able to achieve suitable temperatures. So in the future, we would probably look into better insulation of our molds, or maybe a larger reflective surface. And for all the serious food processing fans, we haven't left you out completely. We cooked quite some food before we started on all the plastic, including this 1 meter chocolate cake using a local recipe from Lamu. I'll let Derek's reaction give you an idea of how it went.
This meets all the criteria that we have for a cake. It is hot, it is brown for chocolate, okay, and it touches every good part in the taste buds.
Aww.
So it's really good.
Thank you so much.
Yeah, so as you can see, we definitely love solar cooking cakes and other good food, but we also think it's exciting and has a lot of potential to apply this technology on other areas where energy is needed. And we hope that this work can inspire more people to think further. So that's it from us. Thank you very much for listening. And if you want to learn more about the whole project, you can follow the videos we made to document the process on YouTube. And now feel free to ask any questions or share your thoughts. We are happy to discuss. Thank you very much.